Okay, so let's do a question based on the alpha beta pruning, right? If you have already gone through the sample paper, then you will see that you have a game tree question based on the alpha beta pruning, right? So let's practice that kind of problem. So what we will look is the same thing. So it's alpha beta pruning, and so these nodes. So basically what we have to find is that uh, which subtree we are going to prune, right? So here these nodes, so this node is min max node, and these nodes are the min node, and again these nodes are the max node, but these are the leaf nodes with the value that is the output of the utilities, right? So what we have to find is that which node can be pruned from the game tree through alpha beta pruning, and we are assuming that we will be traversing from left to right, and when choosing which child to visit first, choose the leftmost unvisited child. So the idea behind this, that how we traverse, is that uh, let me first of all give you the condition for the pruning. So for the max node, when you are at max node, right? So let's suppose that the output of the utilities is v at the max node, and if it is less than, if it is greater than the value of the beta, then in this case you are going to prune the subtrees of that particular node, that particular max node. And if you are at mean node, and uh, let's suppose that the at mean node you have the value v, and if it is less than equals to alpha, then you are going to prune the subtrees of that particular node, right? So this is the condition for the pruning. So the first step is to assign the worst value of the alpha beta to the root node. So you can assign this root node the worst value of alpha, that would be minus infinity, and the worst value of beta, that would be plus infinity, right? And we are said to traverse from the left to right. So we will go left with the value of alpha is equals to minus infinity, beta is equals to plus infinity. We will reach at this node with the alpha and beta is equals to plus infinity. Now you look at this node, this is a mean node, right? So we will be updating the value of beta, and this node will take the minimum value of their successors. So its successors are these, right? But uh, but we will check also this condition, that do we need to traverse this tree? If it is required according to this condition, if this condition gets that this condition is not getting satisfied, then we will traverse. Otherwise, if this condition is getting satisfied, then we will, you will see that what does it mean. So okay, so let me take this one. Okay, so we are at this node, then here the value is 10, and this node is a min node, right? So this will take the value of 10 here, right? And it will update the value of the beta, right? So it will update the value of beta to 10, right? Now again, before exploring this subtree, right, we will check if if this condition is getting satisfied or not. If this condition is getting satisfied, we are not going to further explore their subtrees, right? So we are at this node, that means value of v is 10, right? So 10, we are at min node, sorry, we are at min node, so we will be checking this condition. So we are at min node, the value of v is equal to 10, and the alpha is minus infinity. Is 10 is less than minus infinity? No. So this condition is not getting satisfied, so we cannot prune, right? So we are going to visit this subtree. So we will visit it, no problem, with the value of alpha is equals to minus infinity and beta is equals to 10. Similarly, and now we are at this node, and here we have the value 8, right? So this beta value will get updated to 8, and this node will also take the value 8. So now 8. Again we will check the condition, that will again not going to satisfy. Then again we will visit this one. So here we will have alpha, that is minus infinity, and beta is 8, right? And with this, that value will, that this is a min node, right? So it will try to keep, so here we will have 3, right? Since it is the min node and min is 3, so we will update this to 3, and the beta value will get updated to 3. Now we will go to this this root node, right? And it will pick, it is a max node, so that alpha value with that this node will take the 3, and alpha value will get updated to 3. Now we will check the condition, since we are at max node, and so we will check this condition, that if I want to explore the subtrees or not. So according to condition, v is 3 is greater than beta is plus infinity is greater than plus infinity. No, that means we will explore the subtrees now with the value of alpha is equals to 3 and beta is equals to plus infinity. We will go left, right? And here for this 2, this one, alpha is equals to 3, beta is equals to plus infinity. So again this node is a min node, so it will take the value, that is 2. So beta value will get updated to 2, it will take the value 2, beta value will get updated to here 2, right? Now again we will check if according to our condition, we will check that we want to further explore it or not, or we want to prune it. So here now this is a min node, right? So this will take, here I forgot to update the value of beta, so that will be 2. Okay, I updated here. Let me get rid of this one. So this will get updated to 2, right? Now again we will check at this node. So v is 2 and alpha is here. So this is the min node, right? So we will check this condition. Alpha is 3. Is 2 is less than 3? Yes, this condition is true. So we are not going to visit their subtrees, right? So this subtrees will get pruned. Okay, now we will be back to our root node here, and this is a max node. So max 3 and 2, so 3, we are good with that. No update on alpha. Again we will go to this node, and here this is a min node. Again we will go to the with the value of alpha is equals to 3 and with the value of beta is equals to plus infinity. So this is a min node, so we will check condition, right? So that condition is not going to satisfy, so that will take value 6, right? So this is a min node. Now we will visit this one, right? And we will update the value of beta. So here beta will get when we will visit this one, right? So why we are visiting? Because condition is not getting satisfied, so we will explode it. Again you check the condition, you are at the min node, right? You are at the min node, and the node value is 6. Is 6 is less than alpha 3? No. That means we are going to visit this node, and that beta will get updated to 5, and the value here will be 5 because it's the min node, so it will keep the min value. And again we will check that 5 is less than alpha 3. No. So again we will visit this node, and this beta will get updated to 4, and here we will have 4. Right now again we will go back to root node, and here we have 3 2 4. So maximum is 4, since it's a max node, so that will get updated to 4, and alpha will get updated to 4. Right, so we have answered that which node can be pruned. So this one, this with the pink color.